So now we'll move on to part C. Y equals 1 over 3x squared plus x. Again here, it's fairly obvious we're going to choose the polynomial expression right here as our u. So we're going to let u be 3x squared plus x, choosing our middleman there. And then we can rewrite our equation y, making that substitution. Y then becomes 1 over, not a big polynomial, it's just 1 over u, which is a lot simpler. And to differentiate that, we might want to remind ourselves that 1 over u is the same thing as u to the negative 1 power. So, again, writing down the chain rule in Leibniz form, dy dx is the same as change of y with respect to u times change of u, not w, change of u with respect to x. So again, what we need to do is just differentiate both of these things. So for this first one, we can say that du with respect to x is our other variable here, dx, is going to be 6x plus 1. And then down here, dy du is going to be negative u to the negative 2 power, applying the chain rule, multiplying negative 1 in front, decreasing the exponent by 1, which we can rewrite as negative 1 over u squared. So now I've gotten both those derivatives. I'm just going to put them in here. We're looking for dy du, which was this green part right here. Dy du, that's negative 1 over u squared times du dx, which we've got right here. So I'm going to put it in brackets since it's a two-term expression, and that's our derivative. Again, we're not quite done because we've got a combination of x and u, so all we have to do is replace u with what we originally chose it to be, which was 3x squared plus x. So I'll rewrite this down here. dy dx equals negative, maybe I'll combine it all in one step. I'm going to multiply 6x plus 1 into the top. So I'll get 6x plus 1 divided by u squared. But remember, u was 3x squared plus x squared. And now we've got an expression for our derivative right there. And finally, let's squeeze in part D here. Hopefully you've got enough space left for that. The equation for D was natural log y equals the natural log of 1 minus 3x. Okay. So again, it's fairly obvious here what we're going to choose as our u, so let's do that. Well, first, again, let's use the function notation this time. Let's rewrite this as a composite function, f of g of x, and think about inside and outside functions. So it's fairly obvious that the inside function is going to be this right here, 1 minus 3x. So let's let our u, which is also g of x, our inside function, it's going to be 1 minus 3x. Now that means that f of u is going to be just the natural log of u. And so now if we want to take our derivatives, we know that, I'll try and squeeze this in here. This means that g dash of x is going to be, differentiate 1 and it goes away, it's simply going to be negative 3. And then here, f dash u is going to be, we've learned recently the natural log, derivative of natural log of x is 1 over x. So the derivative of natural log of u will be 1 over u. And so now I'll rewrite the rule in function form. Our derivative is equal to our d dx of f of g of x is equal to f dash of g of x. In other words, the derivative of f, when we substitute g back in, this substitution that we're going to make now is the same thing as over here. When we saw this u and we said, oh, well, we really want an x, and we plugged in 3x squared plus x. It's essentially the same exact thing, just different notation. And then multiplying by the derivative of the inside function g. So let's do that. We get our derivative of f we saw was 1 over u, but again, instead of u, right, I didn't write f dash of u, we want to substitute g of x back in, which is u. It's the same thing. U equals g of x. U equals g of x, which was 1 minus 3x. So this is going to be 1 over 1 minus 3x multiplied by the derivative of g of x, which we saw here was just negative 3. And so this really just becomes negative 3 over 1 minus 3x. And that is our derivative. So you can see this chain rule is really powerful. It's really going to open up doors in terms of the types of functions that we can differentiate here.